All right. Skittles reports the following proportion for the color of their plain Skittles. 21% purple, 25% red, 17% orange, 18% yellow, 19% green. Why they don't just make them all 20%, I don't know. Maybe maybe orange dye is expensive. I don't know. Don't know why. So, what we're going to do is test this. Garrett, did you get Skittles from Tawny?
1 second. My principal's going off on a bunch of kids. I can't hear anything.
So.
Okay, what were you asking?
I'm recording this, so that will forever be on my website.
That's fine.
Did Tawny get you Skittles?
Yes, I do have Skittles.
Awesome. So, I severely overbought the number of Skittles needed. Yeah, I probably got twice as many Skittles as I wanted. So instead of being in a group of 2 with a cup of Skittles, you get your own. So here's what you do. You will get your Skittles. You're probably going to want to count them out on your desk. So I don't care if you grab an extra cup or you can grab some paper towels. But you need to count how many Skittles you have of each color. So let's say that I ended up with 200 total Skittles. And I had, let's see, 40, 55, 36, and so on. So we're going to run a chi-squared test to see if the company is right. They claim 21%, 25%, 17%, and so on. All right? So the way we do this is we need to calculate the expected for each color. Do you remember how to do that? How would you do that? So you're going to take 0.21 times 200, and I get 42. And then 0.25 times 200 is 50. And 200 is this number. That's how many Skittles I had total. I don't know how many you guys are going to have, but it's a lot. So I hope you like Skittles, because I spent $50 on Skittles last night. Yeah, that was more than I needed to. Okay, so you're going to do that for each color, okay? And then we take observed minus expected squared divided by expected, and we do that for every color. And again, it doesn't matter the order that you put these in. So I just like doing big minus small because it's easier for me to do the multiplication that way. So what is our chi-squared term for purple going to be? What's the difference? 2 squared over, do I divide it by 40 or 42? 42. Plus, what's my next one going to be? 5 squared over 50, and I'll figure out the next one. 0.17 times 200 is 34. So this would be 2 squared over 34. And you're going to do that for every color. Then I'm going to end up with a chi-squared term. So chi-squared equals, let's say, 12. Now what do I do? No, so in the past we did that, but for this one, we just keep it in the squared version. So I need to find my degrees of freedom. How many degrees of freedom do I have? 4, because there are 5 categories. 5 minus 1 is 4. Then I go to Rossmann. Okay. Go into the apps. and then I do chi-squared, and I type in degrees of freedom is 4, and I want to do greater than. And my chi-squared term, what did I write down? 12. And let's get rid of all that stuff. And I end up with, why isn't it showing me? Oh, right there. Sorry. My p-value is 1.7%. So what would my null hypothesis be? So I'm going to reject the null hypothesis, and the null hypothesis would say that purple equals, what was it, 20%, and red equals 25%, and orange equals 17%. And then the alternative would say that at least one of those categories is not equal. Okay? Now, once you have yours, you need to go around and put your values here, and then talk to 5 other groups, which in this case is just going to be 5 other people, and get their values, and then sum those all together, and then run a second chi-squared test. Now, is it easier to reject the null with more people or fewer people? Or sorry, more Skittles or fewer Skittles? So if we're flipping a coin, and I flip it twice, and I get 2 heads, should I throw the coin away? No. If I flip it 1,000 times, and I get all heads, then the coin is definitely broken, right? So it's actually easier to reject the null with more people, because essentially your confidence interval shrinks, right? The more people you talk to, the more Skittles you have, the narrower your confidence interval and the easier it is to reject. Okay, so you'll do that, and then on the back side, these are the results from last year, which they're pretty close to what the company said, but they're not the same. So I want you to rerun your Skittles versus last year's results in class, and then take those same 5 groups, so your group plus 5 other groups, and run a chi-squared test against last year's results. Yes?
So for the 3 that you want to add, up?
No, whatever's in your cup is your total. Does it say? Why is there 300 there? Oh, sorry, I read that wrong. 300. Oh, so these are not yours. I lied. I assumed that was different. So you are not using your values. We are comparing these to the last year's, to the claimed results. I'm glad you said something. So this value times this goes here. And then that one is going to be the number from the front page, which is what, 20%? So 21% times this is going to go here. And then what was the next one, 25? 25% times this is going to go here. I'm glad you saw that. Yeah. Okay. And then after that, you are going to compare your group and 5 other groups. This should say last year. I need to fix that. So Garrett, what we'll do is the first 5 people that finish, I will have them write their numbers on the board. So if you just want to keep the Google Meet open, your numbers, your shared numbers will magically appear. And then you can write.
Okay, that works.
Okay. Any other questions? All right. Get to work. And when the first 5 of you that finish, so come write your values up here, purple, red, orange, and then yellow and green.